Welcome back to the third video in hypothesis testing for a single population proportion. We've been dealing with the problem about recycling. What I want you to do is resolve that problem again, but now instead of having a 5% level of significance, I want you to use a 1% level of significance. And just for a little bit of practice, I want you to do the traditional method way and the p-value way. And then I want you to notice something. So I'm going to pause the video and let you try it, and then we'll come back and see what you found out. All right, so you've had a minute to work through these. Let me give a quick summary of what I did here. So we did our traditional method where we did our requirement check. It's a random sample. We show that it's a binomial. We check that NP and NQ were greater than or equal to 5. We will be looking for this. Our null and alternate hypotheses, we notice it's a right-tailed test. Our level of significance now 1%, and we draw our picture, find our critical value. And our critical value to give us 1% to the right means 99% to the left. And on our z-table, 99% to the left is a z-score of 2.33. And running the program on our calculator, we find out that the one prop z test gives us a test statistic of 1.87. And notice now that the test statistic lands outside of the critical region, so we would fail to reject H0, meaning there is not enough evidence and if you want to get really technical, at the 1% level of significance, to conclude that the proportion who recycle now is greater than 25%. I guess I crowded myself there a little bit. Okay. So notice that our conclusion changed because we used a different level of significance. Instead of reject H0, now we're failed to reject H0. What if we tried the p-value method? We would still do the same stuff, do the requirement checks, make sure that we're using the right tool on the right problem, set up our hypotheses, decide our test, and then we run the one prop z test. Doing that, we give the test statistic and the p-value. You need both of those, and then compare that p-value to your level of significance, and you will always get the same conclusion from both methods if you've done it correctly. So it's a way to check yourself. Okay. So something that I want you to notice is if we run the numbers and then decide what we want our level of significance to be, that is unethical. The reason is if you run the numbers and then decide, oh, at 1% we'll fail to reject, so we'll set alpha at 1% so we know we'll reject, or conversely, if I would reject H0 at 5%, so we'll set the alpha at 0.05 so I get the conclusion that I want, that is unethical or dishonest. So what you really need to do is decide what your level of significance is going to be up front, and then run it to see what the answer is, not run the numbers and then decide what your level of significance is so that you get the decision you want. That's dishonest. So finally, let's look at another example here. I want you to practice on this one using both methods. A recent Gallup poll showed that 16% of Americans are underemployed. They have either no job or part-time work when they're looking for full-time work. A random sample of 200 Utahns found that 23 were underemployed. Using a 5% level of significance, test to see if the data indicate that the proportion of Utahns who are underemployed is different from the nation as a whole. and again, solve using both methods. To save a little bit of time, how about we do the requirement check just once altogether here. So I'm going to let you try that. So we'll let you pause, okay? And then we'll come back and talk together in just a minute. Okay, let's see how you did. So we had a random sample. It's a binomial. We have a fixed number of trials, 200. Success is underemployed, even though that's not a good thing when people are looking for work. And failure is not underemployed. So we have two outcomes. We have independent trials, because if I'm underemployed, that doesn't say anything necessarily about my neighbor. So the probability of being underemployed is 16%. We wrote down our known information. N is 200. Little p is 16%. X is 23, because we had 23 Utahns that were underemployed. And then the sample proportion in Utah that are underemployed would be 0.115 or 11.5%. We write down our level of significance and our hypotheses. So our null hypothesis is that the population proportion of underemployed Utahns is 16% since they're part of the nation. But the claim that we're putting on trial is if it is different in Utah than the nation as a whole, and different could be higher or lower, so we're going to use a not equals to here. Therefore, with a 5% level of significance, our critical value, so that we have 5% in both tails together, that means that there's 2.5% in this tail and 2.5% in that tail. So if I wanted to find this guy, I need to look up negative 1.96 and notice that he gives me exactly 2.5% of the area in the left tail. And similarly, 1.96 gives me 97.5% to the left, which means 0.025% or 0.025 or 2.5% to the right. So doing the traditional method, we find our test statistic, which is negative 1.74. So Z, without a C, equals negative 1.74. That lands outside the critical region, so we will fail to reject H naught, meaning there is not enough evidence to conclude that the proportion of Utahns who are underemployed is different from the nation as a whole. And that percentage was 16%. Okay. So that would be doing the traditional method. Doing the p-value method, once again, we do the exact same setup. We do our hypotheses, we talk about alpha, we do the one prop z test and p-value method. You give me the test statistic and the p-value, whereas the traditional method, you give me the critical values and the test statistics. So both of them require two components. And if we compare our p-value of around 8% to our alpha of 0.05, it's greater than. And if p-value is greater than alpha, the p is not low, so we can't reject H naught, so we fail to reject H naught. There is not enough evidence to conclude that the proportion of Utahns who are underemployed is different from 16%. So once again, you'll see how we got the same conclusion in two slightly different ways. And the other thing that I will mention is if we were to take this guy and do his area outside of the test statistic and come up here to Z equals 1.74 and go outside that, those blue areas would be 8%. And notice that 8% is greater than 5% because the blue area is greater than the pink area that we had originally shaded. And the only way that can happen is if the test statistic lands outside of the critical region. So that's why these are two separate but equivalent ways to solve these problems. We'll pause right there.